Welcome everyone to the second day of our IMF conference. Hi, I'm BJ Farrar. I'm from the Getty Museum in Los Angeles, California.
And I'm Mac Lowry, also from the Getty Museum. 12 years ago, with a shoestring budget and no network to speak of, the first Mountmakers Forum came to life and truly changed our lives. What might have been considered a one-time event at the Getty Villa in Los Angeles has evolved into a series of international conferences, a website, and a truly dynamic worldwide group interested in all aspects of mount making.
Today, we're honored and amazed to be a part of this ever-expanding network that has become internationally recognized, which is enriching our careers, our knowledge base, and our profession. We're continuously humbled by the generosity, goodwill, and sheer talent of all of those who join in this endeavor, a true forum for you, by you, and of you. And if my math is correct, as of today, we've had over 1,100 people register for the conference. Truly amazing.
Indeed. As we begin the second day of the 2020 forum here online, we'd like to give a special thanks to Shelley Euler and her team at the Smithsonian, who rescued this event from the dustbin of a COVID-19 world. We would also like to thank our IMF volunteers for today's sessions: Sam Hamilton, Lauren Osmond, Emmy Savakul, Lisa Imamura, Elizabeth Soriano, Laura McClure. And a big thank you to our Smithsonian tech producers, Alex Cox and Johannes Porto.
We're pleased to have this opportunity to be part of today's sessions, which will first delve into the important topic of earthquakes and mitigating potential damage with seismic mounting techniques. And in our later sessions, we'll have an opportunity to see presentations that will incorporate 3D technology into mount making and developing innovative displays.
We hope you enjoy and benefit from all that you experience here. And if fortune smiles upon us, we look forward to seeing you at the next forum in 2022 at the Getty Center in Los Angeles. So please note that your microphones will be muted and cameras turned off during the presentations. We're recording all the presentations to eventually post to the IMF YouTube channel, so we want the audio quality to be as good as possible. We'll also be live streaming on YouTube at the IMF's channel. If you have any questions, please use the Q&A function on Zoom. If you have a question for a specific person, please use their name so they know it's directed to them. We'll try to address as many of these questions as we can at the end of each presentation. Any questions that we can't get to during the Q&A can be brought up during our after parties or through the Slack app. You can also feel free to contact the presenters directly. Each presenter's abstract and bio are in PDF form on the IMF website. And we have a slide that will direct you how to get there. Our first talk of the day is presented by Tim Scornia from the St. Louis Art Museum in St. Louis, Missouri. You might remember him from our tour yesterday if you attended. He'll be speaking today on mount fixtures for a Donald Judd sculpture.
Hi, my name's Tim Scornia. I'm the mount maker here at the St. Louis Art Museum. I've been a mount maker for 7 years and an artist, welder, and fabricator for 15. Today I'm going to be discussing with you a Judd box project I completed in late 2019. So here we have an image of the existing mount that was used to move the object around the building. This was an old idea, a turnbuckle resistance fit mount. The problem with this was the fact that you need to step inside of the box for installation, putting pressure on the structural joints. As you can see here, adhesive was used on the sculpture to join the aluminum. These are the two aluminum plates in acrylic inlay. The problem was any resistance against this joint would most likely rupture the seam. This illustration depicts what was the preliminary ideas. The idea was to stop the object or Judd boxes from rocking side to side while being shipped across the country. So after researching, talking with conservation and installation, and looking at every clamp bracket fixture system I could find, I came back again and again to just a simple right angle framing clamp. Here I'm starting to work out some of the details for how this bracket would be assembled. As you know, as a mount maker, you most likely are not going to be able to find what you're looking for without having to fabricate it yourself. So having the ability to use Autodesk or any system like that is very beneficial. So here we have the bushing block, we have the control block, and we have the threaded rod. This is a drawing of what is the bottom plate of aluminum. Here we have the bottom plate with the locking plate attached with fasteners, as well as the two plates that would be welded in position on top of the bottom plate. Here we have the internal locking plate and what is the pitch angles for weld placement. This image, we start to see what's going to happen internally. So you have this hole here, which is milled out, and this is to accommodate what will be the spring pin to allow clearance for the spring pin to set into. Here's where your threaded rod will come through. This is where your bushing block will be press fit into. And this is what it looks externally. This is what it looks like. This is the threaded rod control block. So this is the bottom block. Here's where your threaded rod will pass through. This spacer here, this is threaded. So this is to allow for the threaded rod to turn within the block itself. And then here's your secondary bushing, and that is to stop it from swaying side to side within the block itself. And again, here's what it looks like externally. Here's your bushing, press fit into the top. The threaded rod, to me, it's even important to show the most minute details down to the spring pin, what size, the hole diameter. This just makes it easier for the machine shop or fabricator, whoever that is, to put this thing together for you if you're doing it out of house. So I think it's very important to break it down piece by piece, component by component, just to allow for you to not have to rework anything in the future. Here we have all those drawings and all the components and how they work together. So you have your bottom locking plate, your top, you have the control block, the bushing block, and the threaded rod, and how they all work together to make a simple right angle clamp, just on a larger scale. This is what they look like when they came back from the shop. Overall, very good job. The external welds were decent. They sat at about 1/16 above the aluminum. Nothing came in contact with the piece itself, so there were no pressure points. There was no welds internally. All the internal welds were fusion welds, or if they were welded, they were sanded smooth, which was all spec'd out on the drawings. And the internal plate here, this is where the LDPE will be attached, and the external plate is where the poly suede will be attached. So to your left, you'll see the LDPE, low density polyethylene, the 32 mounting brackets all on a pallet as they came back from the shop. To your right is an in-process photograph of everything that had to happen before lining the components. So here we have the LDPE after it had been cut and all the edges had been beveled. Here we have some more in-process photos. You have your poly suede, your double stick tape. Velara was used to line the bottom edge where the components came in contact with the Judd box itself. This is where I did all my assembly and beforehand would wipe everything down with denatured alcohol. The polysuede was adhered with hot glue to the external surface of the locking plates. Before every installation or shipment, I always will carry out a test fit. This is an image of myself doing a test fit with one of the other preparators that works at the St. Louis Art Museum. To your left is an image of an objects conservator applying Teflon to the LDPE to act as a secondary barrier. To your right is an illustration done by myself of the installation crew putting on all the fixtures to the Judd boxes. This was carried out because of image rights concerns, and luckily I went to art school so I can draw pictures. Here we have an illustration of the suction cups that were used, 4 to either side. That would be 4 art handlers for each Judd box as they place them on pallets. Here are all the fixtures in position on each Judd box as it was placed on its pallet. This image is showing the slots that were cut into the foam and Velara to accommodate the fixtures themselves within the crate. You can see how the Teflon was used to act as a barrier in between the fixtures and the Judd boxes themselves. This illustration is showing what the Judd boxes look like packed within the crate and how all the foam worked to accommodate the fixtures themselves in all the slots that were cut. Here are the skid mates our objects conservators, Raina Chow and Hugh Shockey, developed. They worked with their contacts to come up with these. I don't know much about them. They could give you all the insight you need. I'm sure they would be more than willing to talk to you. If you have any questions, just email me after this or at any time and I can put you in contact. Here we are loading into the truck. Everything was a success. Moving on to somewhere else in the country for exhibition. Here we are at the end of the presentation. Hopefully it was not too short, not too long. I would also like to thank the API department here at the St. Louis Art Museum, headed by Christopher Moreland. I am very proud to be a part of this department, and I think we do an excellent job overall. I would also like to say, keep making, keep mounting, be safe out there, people.
Thanks so much, Tim. That was wonderful. I'm wondering if you're ready to answer some questions.
Yes, absolutely.
Fantastic. I might start off and ask you one. Can you talk to us a little bit more about the design process? The way that you used Autodesk, was that correct?
And Autodesk 360 Fusion.
Is can you talk to us about that?
Huh? Okay. Yeah.
Yeah.
It's a software program, Autodesk 360 Fusion 360. I have a scaled down version. I don't have all the extra amenities that some of them have, but for doing 2D drawings, it's ideal. And it just makes it easier for me to break down all the different components to then send out to another machine shop if they're going to do that work. So.
Thank you. Fantastic. And how about a little bit more about your problem solving process? The design of it and what you were trying, like what was the problem you were trying to solve, and then how did you come to that solution?
Yeah. So what was going on with these Judd boxes is the way that the panels are joined. There's most likely like a dowel system that's within them, like a dowel rod, dowel pin system that's press fit in, and they are most likely adhered with an adhesive. So we were having an issue with, we thought it might buckle while it was being transported across the country. And I came up, we talked through a lot of different solutions, like building an entire cage that surrounded the entire piece, but all those different ideas would require somebody to have to step inside of the piece or along the outside, and could allow for damage. So doing a simple right angle clamp was the best solution I could come up with.
Fantastic. Thank you. That's wonderful. Can you talk to us a little bit about the, there's a question here and it's saying, was that milled on a metal lathe? I guess they're asking about the manufacturing process.
Yeah, so all that should have been, that was probably done on a Bridgeport. So yeah, it would be on a stand-up mill machine. I was a machinist in the past before I was a Mountmaker. So I knew a little bit about how to do technical drawings like that to make it pretty easy for them to transfer over into their file. So yeah, that was most likely done on a mill, not on a lathe.
Thank you. There's another question here that says, have the Judd Foundation or other institutions with similar pieces adopted this method?
I'm not sure. I don't think so. I mean, I was not in contact with the Judd Foundation. I didn't want to go through that process of contacting the Judd Foundation to find out if I could use these images. That's why I drew everything out. So I am not sure, but we own that particular piece. So that's why I was able to do what I did. But as far as image rights, I can't reuse those images and try and get any kind of, I can't, I can't use them myself.
Yep. Another question has just come through. It says, did you have to work closely with the Judd studio to develop the brackets?
No, I did not. I did not work closely with the Judd Foundation or the Judd studio at all. I worked closely with the other museum that the objects were going to, and we compromised with the solution that could get the Judd boxes there, because we were afraid of shipping them across. They were going to New York, so we wanted to make sure that they were safe all the way up to the Northeast from St. Louis.
And so did you do an evaluation of how well they worked? I guess before I ask somebody else's question, I just wanted to understand, was there an evaluation done of how good this method worked?
Yes. Yeah. So I evaluated. Yeah. I mean, I did a test fit and I went through and I checked the overall consistency of each component. I had to mess around with how it was threaded. There was some press fit, stainless steel press fit fittings that work to hold in the threaded rod so that it can't twist side to side. So yeah, I played with it quite a while to make sure that everything worked seamlessly.
And even after they were used, like it all just worked well after it was used and there was positive feedback?
Yes. So they made it to New York and it was successful. And I heard that everything went really smooth and they will be returning in the next 2 months. So they will be coming back. That's a fairly recent project.
Fantastic. So there's a question here about so the Teflon for vibration, was it used for dampening or was it used for contact issues?
Not for dampening, for contact issues. Are you talking about the Teflon?
Yeah.
Yeah. So the Teflon, yeah, that's for friction. So the dampening system, yeah, there's not really a dampening system within that. But yeah, that's more for friction against the acrylic. So it acted as a secondary barrier in between the LDPE.
Thank you. There's another question here that says, what kind of documentation did you send along with the object about the supports? Did a courier go with the shipment?
Yes, our objects conservators went with the piece itself. And yeah, it had full documentation, an entire breakdown of how to assemble, take them apart. If anything fails, I sent some special tools to take things apart.
Thank you. Another question has come through. It said, did you choose to fabricate new clamps instead of retrofit a standard right angle to save space or for another reason?
It was the scale. So I tried to get, the ratio wasn't correct. I needed to be able to span a certain amount of square footage of the piece to accommodate how heavy it is. Each one was around 400 pounds. So they needed to, a normal right angle clamp, I think on average is about 3 to 4 inches in length. These are 10 to 12 inches in length. So wow. It's double the size.
Yep. Another question is around sort of lifting. So did you have to lift the cubes to place the braces on the corners on the floor side of the cubes? Did you
Yes.
have eight preps hold it while those braces were placed?
No, we used ethafoam. We used padding to put underneath them. And then that's how we got the bottom braces on. Sorry if I
Okay.
didn't show that in the slide, but yeah.
In a follow-up to that, someone's asking, could there be an alternative way to move these without needing 8 art handlers? The pallets are difficult to slide away with that many people.
Yeah, I mean, you could build a secondary skid, and you could shim the sides potentially, but again, I wouldn't try to shim this because of how it's assembled. It's all adhered together. So if you tried to rig it in a way where you would put shims underneath to get straps underneath it, I think you could jeopardize those joints. So I would imagine, yeah, you need 4 art handlers, not 8. So it's 2 to a side, so 4 each to place it.
Yep, thank you. And there's another question about how did you judge how tight to clamp the boxes without stressing them?
That's a good question. So yeah, I played with that quite a bit with the LDPE and its density. So yeah, I mean, how that right angle clamp opens up, it opens its max capacity is just to fit over the threshold of the piece. It's just to fit. It's a very snug fit. And then you just have to tighten it maybe 2 turns to get it to lock. I didn't want to make it over big. So then I would have all this excess threaded rod sticking out. So yeah, I played with that quite a bit also. So I just took into account the thickness of the aluminum, the acrylic, as well as my LDPE and my aluminum plate itself, added all that together and added in about 1/16 of play. So they're very snug fit. You can't really use them for framing. They're specifically designed for just those boxes.
Okay, great, thank you. And then there's some questions here that are related about how much time did the whole project take? And, you know, so how long did it take to develop the solution and just sort of how much time did they take to machine? So lots of time questions.
Yep. So around 6 months, we started talking about how to develop an idea. We had a couple meetings, and then I did a couple preliminary drawings for approvals. Everything I do at the museum goes through an approval process anyways, and that all is stored in TMS so anybody can see it. But yeah, so the approval process, once that's agreed upon, then again, we had to have where the objects were being sent to. They agreed upon paying for some of this stuff. And then after that, I put together the drawings, and then those were sent out. And then once they hit the machine shop, it doesn't take long to do those CAD drawings, maybe a week. And then once they approved everything from their end, and they take those drawings and it's in a PDF format so they can readjust anything that they need to for their particular CAD program or other system that they use. And so all in all, about 6 months.
Wow. Thanks so much, Tim. That's all the questions for now. So thank you.
Mm-hmm.
Back to you, Mac.
Okay, well, thank you very much, Tim, and everybody else. I think our next talk is by Vincent Avalos at the San Francisco Asian Museum in San Francisco, California. He'll be presenting a paper on mounting Isamu Noguchi's 1-ton sculpture, The Seeker Sought.
Hello, everyone. I'd like to thank the Getty and all who organized the IMF for putting this forum together under such insurmountable odds. I'm Vincent Avalos, and I'm so happy to present what has been a project I wanted to do my whole career, the seismic mounting of a Noguchi sculpture. Isamu Noguchi is an artist I've studied and admired since my school days. This is the seismic mounting of the seeker sought. The exhibition we received is called Changing and Unchanging Things and focuses on the connection between the artists Isamu Noguchi and Saburo Hasegawa. The sculpture consists of a 1-ton basalt stone sitting atop a pine stand salvaged from a raised temple. We received the sculpture from the distinguished Noguchi Museum in Queens without any mounts, pins, or hardware of any kind. Obviously, the weight, seismic concerns, and geometry of this sublime sculpture will make for a very challenging mount. Adding to these difficulties are the aesthetic decisions that must be made. The simplicity of the form of many modern sculptures causes any mount put to them to drastically alter the artist's vision. These are photos before and after the mounting process, one taken unmounted at the Noguchi Museum and one at the Asian Art Museum. Perhaps I should have given a spoiler alert, but I wanted you to glimpse the finished product before I showed the details and amount of work put into it. I imagine there will be opinions as to whether the mount was too hidden or not hidden enough. Should a seismically robust mount be maybe even more obvious so that it is distinct from the sculpture? Or should it be camouflaged and formed to blend into the work so as to be in the spirit of the piece? Can a mount design take liberties with the artist's intent? Does it make it into something else? I wished to consider Noguchi's intention as best I could while keeping the mount tastefully visible. I'm very appreciative of the registrar Larry Giacoletti of the Noguchi Museum for allowing me to thoroughly study and template Seeker Sot, as well as other sculpture in the exhibition. Not only did it allow me to mount the sculpture as best I could, but I felt I was able to see it as few others are allowed. I'd like to share some of these study photos. These slides give a very clear idea of the fragility and precariousness of the sculpture. You can see here daylight coming through at the touch point between base and the sculpture. These pictures seem very similar, but were valuable references in templating and reconstructing future mock-ups. This is a picture of the underside of the middle beam. I found this detail fascinating because it reveals what looks like two graphite pencil marks here and one here, which is curious because it means either graphite pencils were used to register cuts on this beam in the time period this temple was built, or Noguchi purposely altered the beam to mimic joinery from a past era. Here we see the distribution of the base of the stone over the pine stand. To analyze this piece, I considered these 6 parameters: acceptable design restraints, mass geometries and center of gravity, earthquake forces in the gallery, force of overturning moment, vibrational period, and stable shape analysis. I worked with our curator, Karen Owen, to discuss acceptable design restraints. We investigated the least offensive way of grasping the sculpture. It was decided to attempt to keep the front of the sculpture as unobstructed as possible. That being decided by the fact that the sculpture had a definite front and was displayed previously with its back close to a wall. Of course, we need to consider mass geometry and the object's center of gravity. For mass, we relied on weights given by the Noguchi Museum. The sculpture's center of gravity is 48 inches from the floor. We used measurements from the sculpture itself and photos to get accurate scale and geometries to model the work. The calculated forces in the gallery were acquired from the primary analysis of Paul Rodler, the seismic engineer who retrofitted our building. Our building is fitted with elastomeric base isolators, which when inputted with a maximum credible earthquake, that would be the big one here in San Francisco, would cause the floor to move at less than a quarter of a G. The overturning moment was calculated at 3,400 inch-pounds. This information allows me to estimate the strength of materials and fasteners needed to resist the anticipated forces. The base isolated building itself has a period of 2.4 seconds. Looking at our original spectral analysis produced by our seismic engineer, I investigated this sculpture's propensity for resonance. I start to get worried when objects begin to approach a period over 1 second. I believe that it had a period that would approach a second or more. I used analysis of similar sized sculptures to come to this conclusion, coupled with the fact that its period would change eccentrically during the duration of a seismic event. This is due to the fact that it is stacked and unfastened. With this information, we can calculate stable shape with mass and geometry interacting with lateral forces and gravitational resistance. If you wish more details on these methodologies, I have written a brief paper which can be found on the Asian Art Museum website under Conservation. The mountain design I finally came up with after a few months of study is shown here. I did a series of detailed drawings to aid my cohort Yutong Yuan and myself to navigate us through the process. The mount consists of two steel plates that form to the inside of the legs of the stand. So here's a plate here showing front, and here it is in the back. They go along the inside of the stand and to the back wall. They attach to a back plate and a top plate that interface with the connection of the stand and stone. So this is the top plate under the stone, and this is back of the sculpture here. These are welded together. The legs also attach to a wall frame here, and three arms are then mechanically attached. One to the bottom of the top plate here, and the other two arms attached mechanically to the back plate. The drawing on the right is a cross-sectional view showing how the back of the top plate interface with the stand and the stone. This marked in yellow. It's the top and the back plate. These plates are welded together. In pink are the arms. This is the side view. And then there's an arm here and shown in 3/4 view to see what it will look like. On the left is the view rotated. The arms are now yellow. We are looking at the back view where you can see 3 bolts and the receiver flange. 3, and this right here is the receiver flange for the mount to rest in. The right drawing details the wall-mounted receiver plate. The Noguchi Museum allowed me to make cardboard templates directly from the sculpture. I used these to make the wooden templates shown that are the exact size of the steel parts. With the help of our designer Marco Sentin, I had these templates photographed, then converted into vectored CAD drawings, which a local machinist used to CNC the parts out of 1-inch thick steel with a water jet. This slide shows the original templates made with the sculpture and the plywood templates, the exact size of the parts. The design of the arm looks somewhat sculptural, though I have been influenced by Noguchi and my intention was to be tasteful. The tapering shape had more to do with structural and mechanical issues than with aesthetics. Here is the top plate template illustrating the footprint of the stone. As a means of both attempting maximum accuracy and having a sculpture to design and assemble the mount to, I created this mock-up of the original Noguchi stand. As fine an artist and craftsperson Noguchi was, the stand was not absolutely symmetrical. I used the template from the sculpture to angle the legs in the precise way they were in the original sculpture. You can see in this close-up of the angle, it may seem slight, but since there are so many parts and so many places for this mount to go astray, I wanted to keep as many parameters in check as I could. These arms will be attached with several fasteners. One of the fasteners goes through the arm. This jig was created to hold the arm at the proper angle while the holes were being drilled. Here we see how it works. There were receiver holes and countersinks to be drilled in these arms as well. Receiver holes fitting welded nuts to increase embedment and deep countersinks for caphead screws. Here it again may seem like I'm attempting to duplicate Noguchi. However, it has always been my predilection to soften the edges of mounts. This has no structural significance, but for my taste, it gives a more pleasing form. This is the forming of the front arm. As per the curator's request, only one arm was allowed to be viewed in front. We also wanted it to be as small as possible, but still have the requisite strength to withstand seismic forces. In this case, we added additional steel. We attempted as best we could to have the form of the mount complement the sculpture. My cohort, Yutong, made these wells, which are much better than I could have done. These had to be impeccable since they had not to only fuse these plates, but have enough penetration to be ground down and have no pitting. This was done with several plug welds and bead welds all around. Here we can see the hole being drilled for bolting onto the base plate, and to the right the arm in its finished shape. Note that you can't see Yutong's weld. Phenomenal craftspersonship. I didn't want to rely just on the one bolt, so we connected flanges to the sides in order to increase the amount of fasteners. This is the finished arm. It might also be a prototype for Boba Fett's starship, or perhaps a 21st century hood ornament. To the left, we see different parts being clamped to the base mock-up. We would clamp the different pieces into place, then lay out welding and machine fastening connections. We worked one step at a time, always reassembling the mount on the mock-up and checking other templates to be sure of the mount's accuracy. On the top of the mount, you can see some UHMW sheeting being fitted. 2,000 pounds would crush foam or felt, especially in point-loaded areas. UHMW has a high compression strength, is archival, and won't damage the basalt stone. On the far right, we can see the nearly finished mount standing on its own. Here is Yutong detailing some of the connections. These are detail shots of the back arms. This shows the arm by itself and on the left being fastened to the back plate. The arms are made of 1-inch thick steel plate and are being fastened to 3/8-inch plate with 5/16-inch bolts. The bolts would have only a few threads into the 3/8-inch plate, so we welded on receiver nuts that not only properly fasten the plates, but locate the arms in their proper position by being inserted into a countersunk hole. Fast forward, here's the finished top section with welded receiver nuts. The top plate and back plate are welded together. In order to keep the plates at the right angle during fabrication and to add extra strength, we made a center gusset. Here it is being cut by hand, old school. Way before the CNC or plasma cutter is set up, I'll have sliced through this steel. You can see here where the gusset and receiver flanges are tacked in place. The receiver flanges help locate the arms and strengthen them by inhibiting their side-to-side torsional rotation. In order to assemble the mount around the sculpture, most of the parts have to be mechanically fastened. Creating an interlocking architecture ensures proper location of the hardware, as well as absorbing some of the forces the hardware is taking. Once everything looks properly aligned, we will go over the tacks with solid welding beads. When painting out the arms, we decided not to give an exact faux treatment to the surface of the sculpture, but to just give a color to fool the eye at a glance. We also considered the different views one would have, as you will later see. The top plate is now ready with UHMW and painted. The wall we attached to was designed to carry significant loads. Steel framing covered in structural ply, then finished with sheetrock. The screws are rated each at 1,000 pounds of shear. That's at the structural ply. The sheetrock would be easily crushed by the shear forces, causing the screws to bend or pull out of the ply. Knowing this, we cut the sheetrock out of the area of the steel frame and added another layer of structural plywood. Now, not only would the frame be mounted directly to the ply, but the screws would have the proper embedment. The mounting plate is now ready to receive. Okay, the mount fits the temple stand. Here we're preparing to fly the eagle for takeoff. And the eagle has landed. So far, everything fits perfectly, but we're not out of the woods yet. We have to do the final fitting of the arms, which will take a couple of days. In the interim, we've strapped the seeker down. The arms were tastefully painted and ready to go, but the paint layer made the arms too tight for their receivers. That's what grinders are for. Once they slid in place, we added some epoxy putty to get an exact fit to the jagged back. Here's the epoxy putty here and here. We used 5/16" bolts to fasten the arms. To reach in these tight areas, we made special wrenches. The front bracket, fortunately for us, fit like magic. Set screws in the side of the receiver flanges were put in place to eliminate any torsion, no wiggling allowed. We can now see the seeker. No camouflage here. This view would only be seen if the guard were not in the room. We decided to paint the back of the mount the wall color. If they were painted the sculpture color, it would, in my mind, alter the seeker significantly. My feeling here is that we can see the mount, but it is not a complete eyesore. It had to be a little bit of a beast in size, with 6 fasteners at 1/4 and one 5/16" bolt. I placed the arm between textured transitions. This seemed the most unobtrusive choice. Here are some accurate gallery shots. In my self-aggrandizing mind, from the patron's perspective, these mounts are fairly inconspicuous, and when they are noticed, they are not offensive. I believe on the right you can see why we painted the arms the wall color. I'd like to point out I took advantage of Noguchi's notch in the beam to complete the securing of the back and top plate to the central beam. Lastly, we add bolts securing the inner side plates to the floor. One here and here. And a cover plate for the back wall frame. The seeker sought. With friends. Thank you very much.
Well, thanks very much, Vincent. That was really an excellent presentation and impressive mount.
Thank you.
We'd like to start the Q&A session if you're ready. And Sam, you'll take us into that?
Yes, I will. Hi, Vincent.
Hello.
I'll just start asking you some questions.
Sure.
Oops. Okay, the first one is, do you feel like you learned anything new for yourself about Noguchi after working so incredibly closely with this object?
Oh my God, that I feel like Noguchi is always teaching me something, and I don't know if I learned things, but it made me think of a lot of questions, and certainly in the overall exhibition, understanding his relationship to his culture and his cohort, Saburo Hasegawa, how they influenced each other and their friendship, and then looking at that and how that relates to their sculpture, certainly was very, very inspiring and something that I didn't really know before.
Yeah, wow. Such a beautiful project, Vincent. There's another question about, is there any reason why the original museum didn't use mounts on the sculpture?
You know, every museum has a different culture. They're not so concerned with earthquakes in Queens, although you know they might be, but they're also you know they want to. It was Noguchi's New York studio, and I think that might have something to do with it. They want to try to keep things as kind of historical as possible, and so those kinds of concerns for them, I wouldn't. You know, we have other concerns at the Asian Art Museum, but for them, I think those trump some of our concerns. But you'd have to ask them, I suppose.
Yes, sure. There's a couple of related questions here. So was this a permanent exhibition, or how long was the sculpture on display? Because I guess there's this real thing about, you know, that decision making and for the mount, you know, and the risk and sort of how long it was going to be on display. So can you talk to us a little bit more about that?
Well, yeah, the exhibition was only up for I think about 2.5 months, and I know that sounds like a short time, and why we put so much like why didn't a more liberal risk assessment go along with that? And at our museum, we sort of and especially as I get more and more experience, and I take seismic events more and more seriously. It's more of our museum risk assessment as opposed to individual sculptures. Someday we're going to have a catastrophic event, and on that day, whatever piece we have on exhibition is going to, you know, it's going to receive, you know, whatever damage happens during that event. And so we don't look at it as per sculpture, but it's like eventually this is going to happen, and we need to be prepared for it in any event.
Yeah. And I guess to that, I was curious as to how much it cost, because it just looked so complicated and complex and time consuming. Do you know how much it cost in the end?
Yeah, I don't know exactly exactly how much it costs. It was certainly, not just my labor, but we hired Yutong is an on-call that we've had working with us for a few years now, and I'm very grateful for his fabrication expertise. And then the amount of materials, was, certainly, I don't know, I would say around $5,000 or more in materials. But I also look at it in terms of what we spend during exhibitions. I mean, certainly plexiglass just to cover everything up costs that much money. It's all sort of relative. I'm not the money person, but I try to advocate as much as I can for, if we want this object to survive a seismic event, this is what we need to do for it. And so I work very hard at our museum, kind of politically, to advocate for the work. And I want to also thank these forums, because and being allowed to talk during these forums, because my museum actually sees that and learns to appreciate the work that our department does more. And so making this visible, it's nice to be able to express ourselves and show our work, but it also really helps in advocating for the importance of seismic mitigation.
Absolutely, Vincent. Such important work. I guess there's a related question here around, would the original museum want to keep your mount for their sculpture? Is that an option?
It certainly is an option for us. We don't mind, sharing our work. And sometimes there have been instances where they say, "Well, should we charge them?" And I always advocate for, that we should just let them have it. Although usually when I make mounts this large, I have to say honestly, no one really wants them, because there's no way of really storing them, or they'd have to pay me to try to install it in the place. So again, money becomes an issue when these sort of things, when we make these suggestions.
Yeah. So John asks, was there any kickback from curators for not showing this great piece in the round?
No, it had been, when it was originally shown at the Noguchi Museum, it was shown against the wall. In this particular show, it was shown in the round at the Noguchi Museum and other venues, but and so they've seen it displayed in different ways. I would have liked to have shown it in the round too. The other issue was that there was a space issue in our exhibition, and things had, we only had a limited amount of space in our galleries, and it just, the way it was designed, it was easiest to put it against the wall for a number of those different reasons.
Thank you. There's a question here from Jane that says, were you able to get all the needed templates without rigging the sculpture, or did NY planning steps include handling and rigging?
I actually was able to make all the templates without rigging the piece, and I sort of, for instance, like that footprint, I was really worried about getting that the footprint of the piece, and so I had to piece, like a puzzle piece, different templates together and go around it, and I was actually really afraid that, because the more components you have, the more you can create inaccuracy, and I was very fortunate that I was able to keep the accuracy without having to rig the stone. But yeah, I was really worried about that.
Yeah. So there's a couple of related questions here around, firstly, were there any quakes during the exhibition?
I So I mean, there are always there are constantly earthquakes in California. I don't remember there were any things that we actually felt. I don't during the exhibition. So I would have to say no. Of course, there was probably like a 1 or a 2 happening, rattling around somewhere as they do weekly, but nothing that you can really feel beyond like the ambient, vibrations you get just from wind and machinery and walking and things like that.
Okay. And so there's another question here from Jason that's around, was the entire exhibition space constructed or retrofitted in consideration of seismic activity?
Yes, definitely. We always try to, the original, the museum itself was, we put a lot of thought into thinking about seismic activity. The walls were built to get seismic mounts into them. And even in that case, I retrofitted the walls even more for this particular piece. And then in the installation itself, the different pedestals and things were engineered thinking of seismicity, certainly.
Okay, and I guess from my perspective, all this, I live in Melbourne, so earthquakes are not as common. And I guess I'm just wondering, what sort of consideration is there around damage that would occur to the object if there was an earthquake? How do you determine that? With the mount and sort of all that decision making.
Well, I mean, I'm not sure if I understand the question exactly, but we try to keep us, we don't want to have, of course, any damage at all. And sometimes that just can't be helped. Even if, for instance, if we had, a giant quake and our base isolators failed and, things happen, then we really can't do too much about that. But our building was I think I showed a slide in there that showed the floor spectra in our building, and that was to show whatever pedestals that we have put into the building, how they would perform, and they want us to build our pedestals not to anticipate an earthquake, but to be very, very stiff, and the building itself will do the work of tuning itself to the earthquake. And so we try to create a system that's very, very stiff when we can. I could talk about this for a while. I've talked a lot about it in other venues, but residents can be a big problem, even with a base isolated building, and it has to be considered even more so in a base isolated building because you're changing the tuning. You're basically retuning the building. I don't know if that really answers your question, but yeah, these are trying to mitigate. They're really difficult problems, and these decisions you have to go piece by piece. And we try to create some sort of standard in our building, and we're very fortunate in our building that we have, it pre-engineered, but we still have to think a lot about it.
Thank you. Yeah, it's just great for me to hear that and learn about that. I was just thinking about all that modelling and how do we do projections and how do we sort of guesstimate, I guess, any potential damage when we're constructing the mounts. So thank you. We've got a few more minutes. We might just go a little bit longer. There's a question here around what epoxy putty did you use? A very practical question.
Yeah, we use epoxy is epoxy sculpt, which is I think a lot of other museums use it, and they're it's a pretty common 2-part epoxy putty.
Thank you. Another question here from Ian, which is how often do you engage an engineer to do design or analysis on mounts, and how do you decide if professional engineering is required?
We do it, I don't know, whenever we get, I mean, I wanted to bring an engineer on this particular piece, but it just was not within our cost. But certainly I would have demanded it if I had some really larger questions. For instance, all the calculations that I showed and that I've talked about before, it's basically sixth grade algebra. It looks really scary when you're looking at it, but I'm not a great mathematician, but if I can work out, like if I know what the fasteners can take, if I know what kind of forces to expect, I can use pretty simple calculations to understand things. Now, if I get to a point where that's not going to work, that I'll get to a point where this math isn't going to help me solve this problem. I can't do finite element analysis or differential equations. I'm not that good of a mathematician by any means. And then at that point, if I'll start bringing in an engineer, and I'll tell the museum, look, if we need to go further with this, we need to bring engineering into an engineer into this. And so yeah, and I have some really wonderful collaborations with engineers, seismic engineers in the Bay Area, and I've learned a lot from them. So I'm really grateful for those instances when we can bring in engineers and we can afford that.
Absolutely. Amazing. And the final question is, was there ever a discussion about the possibility of pins going up into the basalt element instead of obstructing the outside?
There was not, and mostly because I have occasionally done that in the past with our own pieces, and usually there were cases when there were already holes in the piece, and so it had already been, this sort of invasive process had already begun, and so we try to avoid that when we can. And this was a borrowed piece, so certainly I don't think that was a question. And the Noguchi Museum is pretty sensitive about those sorts of things.
Okay, thank you. Thanks so much, Vincent. That's it for the questions. That was amazing. Thank you.
Thank you.
All right. Well, thanks to everyone for their contributions. Our final presentation for this morning session, or first session as it is, will be by Ted Gardeline and Monica Shaw of the Anchorage Museum in Anchorage, Alaska. Their presentation is titled Shaking, Not Stirred.
Good morning. I'm speaking to you from the unceded land of the Dena'ina in Anchorage, Alaska. I would like all of us to take a moment to honor and acknowledge the Indigenous people who have inhabited and been caretakers of this land, and thank them for their past, present, and future care of the land, rivers, mountains, and animals. Ted and I would also like to thank Shelley Euler, BJ Farrar, and the organizers of this conference for allowing us to present this paper. We will be sharing the damage that occurred to the Anchorage Museum almost 2 years ago, and highlight some insights we gained from that disaster. Much of what we share today includes shocking images, not meant to pass blame, but rather to focus on what we can learn and how we can prepare better for the future. I'll set the stage, and then we'll jump into the mounts and sort of the things that we learned. Anchorage is the largest city in Alaska. With the surrounding communities, it houses almost 400,000 of the over 700,000 people that live in Alaska. Although small in numbers as compared to other urban centers in the U.S., the land area that Anchorage encompasses is larger than expected. Although the scale of spaces in Anchorage and in Alaska is large, we do not have the high population density of other urban centers. The Anchorage Museum is one of the main draws downtown for both our community and for tourists. The 247,000 square foot building consists of 5 different buildings or additions. They are merged to appear as one museum from the inside, but each addition was built under different standards and with different materials. The museum opened in 1968 and opened editions in 1975, 1985, 2009, and 2017, along with major renovations of many of the older spaces. Today, there are almost 80,000 square feet of exhibition space. Our mission is to connect people, expand perspectives, and encourage global dialogue about the North and its distinct environment. The museum welcomes over 200,000 visitors, including 20,000 children, through camps, classes, and school trips. It serves its statewide mission by organizing and presenting programs and exhibitions in Anchorage, as well as by traveling exhibitions throughout the globe. The museum endeavors to serve the widest possible audience and to provide a cultural center where all of Alaska's cultures feel welcome. With a staff of under 70, the museum presents and hosts more than 1,000 programs and events each year, offering a wide spectrum of culturally diverse programming. We present and curate about 20 exhibits each year, giving particular focus to the art, culture, history, and science of the North. The facility includes galleries for exhibitions of our permanent collection as well as borrowed exhibits, the Imaginarium Discovery Center with hands-on science exhibits, the Thomas Planetarium, and the Smithsonian Institution's Arctic Studies Center and the Atwood Resource Center, which provides free access to the museum's archives and library collections. The museum cares for a large variety of collections typical of municipal museums around the country. We're caretakers of 27,000 individual objects and artworks. This includes a survey of visual arts in Alaska from the 18th century to the present, with an especially strong collection of indigenous art. We house objects of daily life of Athabaskan, Inupiaq, Yupik, St. Lawrence Island Yupik, Sugpiaq, Anungan, Tlingit, Haida, and Tsimshian peoples. Our archives house over 800,000 historical and documentary photographs featuring images from the late 19th century to the present. Furthermore, the museum has an ongoing partnership with the Smithsonian Institution, displaying 600 objects from the National Museum of the American Indian and the National Museum of Natural History. At 8:30 in the morning on November 30th, 2018, a 7.1 magnitude earthquake rocked the Anchorage area. It was centered about 8 to 10 miles north of downtown Anchorage. It lasted under a minute, but felt much longer. About 5 minutes later, a 5.7 magnitude earthquake occurred. These two events together caused the most immediate damage reported nationally. Areas of the building were damaged unequally. Some areas had significant damage, while others had minimal. The most damage was from fallen ceiling tiles and unsecured items in personnel offices. One of the ceiling tiles in our newly renovated Alaska exhibition fell and hit a sprinkler head, causing it to release. I'm going to skip the details related to the work done around the building to clean and prepare the museum for staff to return and for the public opening. It was a monumental undertaking, and of the staff allowed to work, most worked 12-hour days or more. Without the extensive work done by janitorial, security, facilities, exhibits, and collection staff, we would not have been able to open the museum 4 days after the earthquake. Instead, with the remaining time, we're going to focus on mounts and what we learned from this event. We had newly made mounts, older mounts, bulky ones, minimalist ones, the full range to analyze. Prior to this earthquake, both Ted and I approached mounts by focusing on the object or the artwork. Now, however, we also consider the building and all the connectors between the object and the ground. For a wall-mounted object, it matters if the wall is an exterior wall, structural, temporary, and which floor it actually is on. For deck-mounted objects, similar questions are important. Which floor, which building addition, is the pedestal secured or weighted? How far from the floor is the object? All these need to be considered. In fact, they seem to be as important as whether a mount is minimal and just cradles an object, or if it grips the object and restrains it. In the image that you see now, these are temporary galleries on the first floor. Objects in the pedestals are about 30 inches from the floor did move, well, those without mounts, such as baskets or small beaded sculptures, while heavier objects closer to the floor did not move. These two ceramic sculptures on the right surprisingly did not fall. Their bases are not attached to the parts above, and we're unsure why they were unharmed, but we assume it's because they are on a low platform and not on a higher pedestal. In this image, on the left, there's a temporary gallery on the third floor, or this is the temporary gallery on the third floor of the 2009 edition, which moves quite a bit during earthquakes. These weighted pedestals are not secured since it's a temporary gallery, and we found that the cases moved very little. But the same was also true of small objects, though we had expected more displacement. In the newly renovated Alaska exhibition, which is on the second floor of the 85 building, the cases were all bolted to the concrete floor. This was something that was the renovation in 2017. And the objects in these cradle mounts did not move at all, which was kind of what we had expected.
So in the case of the ivory pieces that you see in this image, one of the things we noted is that sometimes restricting an object can also cause more damage if the mount is one of those really unobtrusive mounts where it's just cradling an object. So in this case, you can see where these are minimalist mounts, and the two sets of pickle forks and letter openers, they just have little cradles. There's nothing restricting anything from jumping out of the mount, and they're just these little U's. But because the whole mount could move, we don't see the kind of damage, which next to it you see these umbrella handles, which actually had mounts that, you know, when we tested them out, really protected the umbrella handles. But with the violence of this earthquake and the fact that the acrylic base was double-side taped to the glass below, which we thought would benefit the umbrella handles since they're so top-heavy, actually worked against us. And so then the movement of those very tall objects, they came out. And we fixed that since then, but we have thought about that a lot. And so in this other mount that Ted just made recently, we kind of applied that same principle.
It's on a cradle system. That consideration is to make as much full contact around the sides of the kayak without going up and over, and getting an exact fit. And because of the different shape, you can't really see underneath the kayak, it was important to really reach that optimum contact point. The other important thing was to tie in both cradles with a connection 1/4 inch by 1/4 inch brass square plate, and that stabilizes those 2 points. The whole idea was to set it up where if it was going to move around, it was going to move on one point, which actually has the whole base.
The whole base will move rather
right.
than two different posts.
Separate points, yes.
Separate points that would then move independently of each other. But we found with these lighter objects that aren't in danger of moving great distances in the earthquake, that if it actually, it can move with the earthquake. By allowing a little flexibility, you actually limit the kind of damage that you might see. And so in this case, we just have placed the mount on the deck.
Because the kayak is not adhered, yes, it's not going to, the kayak is not going to necessarily bounce out of the cradle. It's going to slide a little bit back and forth in movement before. I just don't see earthquakes jumping things out of their mouths.
In this, back to what I was talking about earlier about the knowing your building, because really that's where we found where objects jumped is it had to do with what it was sitting on. We still don't think objects jump out of their mouths. There's usually something else that's at play. It's the juncture of the building to the case, whether it's external wall, interior wall. It's been really working towards our favor to have this movement to allow the kayak to move.
As we mentioned earlier, knowing what type of wall can matter. It might seem obvious, but in our fast exhibit changing environment, some of our temporary walls are weighted, or as in this case, we thought this temporary wall, which is actually full of small exhibit cases, was tied to a structural, either the ceiling or the floor or the structural wall behind it. Sadly, we discovered this wall was not secured to any of that structure except for at the bottom. And so what we discovered with all the objects that were in these individual cases, which were stone and low-fired ceramic lamps, they moved from front to back at least twice. And considering the damage we saw on the plexi fronts of these cases, we know that they did do this, sometimes more than twice. And for the future, because of that, we now require every single object in these cases to be mounted or have a specific mount to restrain it. The next exhibition that we had in this wall or in this space centered around cameras. And so luckily, because we had talked about the earthquake and the implications with this wall, Ted was able to implement some of his ideas, which he'll share now.
Some situations have more than just one object. In this case, there's 3 cameras that normally, possibly, they would have just been placed on the plinth. Yeah, they're just basically tabs, which 1/4" brass on a 1/8" round bar that's placed at locations front, side, and back, to assist in the aesthetics that, of course, have been painted out. Placement of those tabs are critical so that there's contact on all 4 tabs on each camera. And actually, the shape of the object dictates that it's very difficult for me to see this camera tilting up or back, but I can see it going left or right, and that's why you have longer tabs on the sides than you do in the front. Well, this is a case where the camera is very tall and narrow compared to some of the other 35mm that we have. And if you look back at, if you think about the box cameras that we looked at in the tabs, this particular camera obviously needed higher tabs, longer tabs. So I did put 2 in the front here, 1 on each side, and there's 2 in the back. So it's very stable, and because it's so tall, it was necessary to use the higher tabs in this situation. For the Brownie movie camera here, I utilized the tripod contact, and when I was asked to make mounts for all these cameras that had that capability, I wanted to know if I could utilize that, which I could. It was accepted, and it allowed me to make, in this particular case in the Brownie, a long base, and then that's screwed to the camera with the 1/4 Of course, everything's felted off. And then I was able, in this situation, to raise a stem to the center of that base plate, which then gets inserted into the tube.
And one of the nice things about the Brownie that you did is you could have just done tabs and had this on the deck, but by doing this, you were able to elevate it and give it some more presence. And from a curatorial perspective, that was desirable. And so sometimes we do just put things on the deck because of time, and we don't have the ability to make these individual mounts. And an individual mount that would have gripped this entire camera might have taken much longer, but by utilizing that point, you were able to efficiently do all the 40 cameras that are in this particular exhibition.
The luxuries of these mounts for these cameras is that it's a mechanical application, and that makes it more efficient in my opinion, as well as gives it that presence you're talking about. You can elevate it more.
So on this mount, which it's really nice to be able to, in the same principle with the cameras, you can utilize safe holes and other items that are on the mask, which people have been doing for many, many years, but I really like this new system you've set up. Do you want to describe it, Ted?
I wanted to utilize the holes where the straps were, but I've seen hooks and other designs. I just thought of this tab on a post that could be, that would be through the holes where are located on the mask, and it's seated in a good tubing that allows me to get a lot of threads in the tubing to capture the post off of the tab. And the holes dictate, how big or what the diameter of your post is going in there.
But I also like that you put suede on the, obviously to protect the contact point from the brass to the mask.
This whole system is based on this cross piece that holds the the sides of the mask together, and then there is this additive extension off the tube that reaches down to the inside of the chin, and that is formed to match exactly where that point of contact is. That is then set up where another tube allows for a drop clip to be utilized. So the object itself, the mask, can be moved half an inch to an inch at most
away from the wall.
Away from the wall,
if we decide we need more. But I really like the fact that the mount is gripping the mask, and we don't have to worry about having the mask come out of the mount. Oftentimes you see on masks, you'll see the tabs come around to the front.
Right.
To hold the object has to dictate it, because the holes on this mask, which is a contemporary mask, are quite stable, and the wood is quite stable.
Exactly. Yeah. If you came across an artifact mask where that couldn't be utilized, obviously that's something to think about. But I think for stable masks, this kind of system for me is very direct and minimal.
In the Smithsonian Gallery, which is in the 2009 edition on the second floor, the mounts hold each object and attach to vertical rods under tension. In this gallery, no objects fell. During the planning of this exhibit, there was testing of vibration transfer and to make certain that the mounts hold the objects securely during an earthquake. They were extremely successful for this. As you can see, some of the mounts blend right in and some are apparent to the visitor and can seem a bit bulky. The mounts were not removed after the earthquake, though there was and as this project and casework, which was actually the problem, we're all interested to see what effects of these mounts, these more bulky mounts, will have on these objects, but also these mounts have held these objects, or by the end of this exhibition, for a minimum of 12 years and perhaps longer. We'll end here so that we can all join in a discussion about these and other mounts while thinking or addressing issues around earthquake mitigation. Chanan to all the Anchorage Museum staff members who made this presentation possible and helped during the disaster. And Chanan to all of you for listening to our experiences and our thoughts and joining us in the conversation to come.
Well, thanks very much, Ted and Monica. As we set up to take questions, we'll be joined by our Earthquakes and Mounts panel, comprised of Vincent Avalos, Jamie Haskell, Richard Hards, BJ Farrar, Mark Maton, and myself. But we'll start off first with questions for Monica and Ted. Sam, would you like to assist us with that?
Absolutely. Let's get started. Okay, so the first question is, for these small object mounts, like the cameras, how did you secure the bases that rest on the case? Did you allow for movement or make the bases rigid in the cases?
So the cases themselves have those little bases in there that are sort of restrained and minimally they can move, and that we think might help a little bit when the bigger wall moves, because that was one of the things that we found is that the pedestals that were restrained in a space that is moving a lot, all the transfer went up to the object, and then the object was the point at which most of the momentum continued. And so you kind of had a whip effect with the objects, and we were trying to avoid that, which is kind of what we were trying to describe with the ivory pieces. By having the whole thing move a little bit, you restrict it from all the transfer of energy that goes to the end of the object. Does that make sense?
Yeah. Thank you, Monica. That's great. I've actually got a couple of questions. Can you talk a little bit more about that vibration testing that you were talking about happened in the gallery that had the NMAI objects? Can you explain that process?
Sure. I wish I could remember more. It was about 10 years ago or more. Michelle Austin Dennehy, who is a conservator, was contracted at the time through the National Museum of Natural History and the National Museum of American Indian to test the vibration that might occur in those cases, because they specifically were concerned about those rods that all the brackets that then the mounts attach to. So there's a lot of points, and there's a lot of concern that if things come into resonance and how tight the rods are and how much vibration transfer would occur from one rod to another. And so I can't remember the name of the sort of, it's not a data logger, but it's a vibration logger that we utilized. And we just we put them on the rods and then put them on the brackets so that they kind of imitated what an object would be, and then we tested it. We're lucky because that side of the building does not get a lot of car traffic or truck traffic, so we didn't have to worry about vibration, low-level vibration that you might see in bigger cities. And even, you know, throughout the building, we didn't have that. But Michelle could speak more to that, and I think contacting her would probably be the best. But what they discovered is that some of their concerns weren't necessary at the time, but now that we've had this really large earthquake, I think it's different, because I think at the time we thought if we had an earthquake this large, there'd be bigger issues. There might be, not in that building, but in the rest of the museum, that there could be concerns or issues that were probably more personal safety and building safety related. And so if the building is failing, I think, you know, worrying about the objects, you know, they become not as important, frankly. But we try to do the best we can, and so we were trying to limit anything that would happen in that building, which had some of the best building specs that were available at the time for earthquakes, and it did. It really, but the building does sway a lot. I mean, it probably moves at least a foot at the top on the 4th floor during that earthquake. Minimally, it probably moved more than a foot. I think some of the estimates for other buildings in Anchorage that are a similar height and how much they moved were over a foot in distance. The buildings swaying, I think they were up to 4 feet movement at like 10 floors or so or higher.
Wow. My heart goes out. I think it's just, wow, just going through something like that is just awful, I think. And yeah, I feel for everyone who's had to go through something like that. And you're right, people come first and then our objects. But yeah, wow, thanks for sharing that. There's a question back here that goes back to the camera display, and it's the camera tabs are very nicely done. So there's a lovely compliment then. But the person's asking, did you consider brazing, soldering a flattened rod to the bottom end of the flattened tab instead of onto the face?
Did that make sense, Ted?
I'm going to try to figure that out. The brazed rod is going where?
Sorry, that question's just disappeared. Let me go back to that one.
I'm sorry.
I think they meant, Ted, like on the bottom of the tab rather than so that, you know, you've made some of those tabs before where it appears flat above the deck, and the rod only goes into the deck.
Right. And so the question.
So they're saying, did you consider brazing or soldering a flattened rod to the bottom end of the flattened tab instead of onto the face?
Oh, okay. Well, structurally, I found it stronger if I can get a little purchase on the tab, and the round is sanded down where it becomes almost like a half rod. I just find it stronger because I have a little more brazing surface to work with versus just this rod brazed at the very end of that tab. I see where it's going, where it's just like a flat tab going down versus you see this round bar or half round bar going in. But structurally, I think I found it stronger because you could actually bend that at that point. It's just my technique.
Yep. Thanks, Ted. There's another question here from Kimberly, and it says, did you have any objects secured with wax? And if so, how did that work? And did you have any, or did you tie any of the objects to mounts with monofilament for extra security? And if so, did it cause any damage or keep anything safe?
So we do have, in that exhibition where the ivory pickle forks and letter openers, you couldn't see, but that entire case, I don't know, it has like 50 pieces of ivory, and pretty much 3/4 of the ivory in that case are all secured with wax because it's on a glass shelf. So there was no opportunity to drill, which is why we had those other mounts on acrylic rather than directly into the shelf. And then we had some up on the third floor as well in those really tiny cases that I showed photos of, tiny pedestal cases. And the wax, I would say, is all about the application and the person who's making it. And the wax does not have good shear strength. And so if you make the ball and then you squish it too much, you don't have good strength. But we had those small items. I think only 2 or 3 of those ivory figurines moved. Everything else stayed. And so the wax worked out really well. And we can't use it for all walrus ivory, because if it's older walrus ivory that's decayed, you can't use the wax on it, and you need a mount. But for some of the, the good ivory, that worked. And then for the question about monofilament, as a conservator, I'm really not a big fan of monofilament. For some of the organic and the kinds of objects that we see up here in Alaska, I should say that I deal with a lot of organic materials up here. We're a contemporary art museum as well, so we have lots of different materials, but I find the monofilament to be a little cutting, and so oftentimes we'll use other materials, and then Ted has tubing, or we have medical tubing, or different kinds of polyethylene tubing, shrink tubing, that we will put around it to keep it. And in this situation in 2018, we didn't have any that we could judge, but we have done that in the past, where we have secured with additional either coated wire or thread or other things that might not be as strong as monofilament. But I don't know, Ted, if you wanted to.
Hey, Mackenzie.
All right, well, thanks very much. We'll now begin with the earthquakes and mounts panel discussion. And I thought I'd lead off with the first thought that goes through my mind when I'm designing seismic mounts. That being, what can go wrong will go wrong. So putting it out to the rest of the panel, any choice words you guys have to live by?
I would say take everything into consideration. There's a lot of complexity.
I know I felt very, in listening to I really liked the concept of kind of the chain of custody in terms of, what is the base attached to, what is the wall attached to, what is the floor doing? Because to me, it's all about, how are the forces of support being, all carried. So I really appreciated as you kind of went through that litany of what is attached to what.
I totally agree.
I was really fascinated with Vincent's approach, because we wish we could consult engineers more, but I really liked sort of how you were thinking the same thing, but in a much more scientific way and more precise way, looking at the weight of the sculpture and then approaching how you did your mount that way. I wish we could do that more often, and that we had more knowledge about the building. And because we have 5 different buildings, we're not as knowledgeable about each foundation or each construction aspect.
Yeah, well, I was very fortunate. I've been really, really lucky that I've had, we've had our building engineered and everything. So it's predictable what our floors will do. We have like an acceleration for every floor, and it was interesting too. In just that, we have 4 floors in the building, and the 3rd floor has the greatest amount of acceleration. And so and if you think of it as like doing the hula, it's like that. It's as the further you go up, every floor will have a different wave that hits it differently. So even in our building, it's very eccentric, and I'm just lucky that I've had the information to work with. And then we've had like I think you were talking before about, I'm not sure if you were referring to accelerometers, but you had things that were testing the vibration on the pieces. And so we've had a few of our larger sculptures tested like that, and engineers were able to give us, detailed analysis of the periods of those sculptures. And so we don't have enough money to go through every single sculpture in our building, but I can take that information, compare it to other sculptures, and then look at our floor spectra to see how that all matches up. But we're very fortunate, absolutely, and to be able to do that at other places. It'd be really interesting to find some way. I don't know. I think that's one of the things that we can do as a group, is to figure out some way of creating a system of kind of understanding our buildings, and maybe even, I don't know, funding further investigation into each of our museum structures, because it's so important. I don't know how else to get the information except for just to have an engineer come in and do the analysis.
Yeah.
I was so impressed, Vincent, with your presentation, and I didn't get to ask this question, but obviously for Mountmakers in large sculptures too, and small sculptures, center of gravity is so important, because when the quake happens, it seems like that center of gravity is connected to the earth in such a way where if you don't find that center of gravity and mitigate the mount or work the mount around that, then things going to go wrong. Yeah, they're going to go wrong. So the question I did want to ask you is, how did you determine that center of gravity on that biomorphic shape? I mean, I can see a cylinder.
I literally made a model of it. I'd saved it, but like I actually even I just got that epoxy sculpt, and I we did with photos and drawings. I made a drawing. I tried to add lead to it to get it's the proper, because basalt is actually like much heavier than epoxy. So I just tried my best to model it as best I could, physically, because I'm not I'm not great with math, I'm not great with engineer, but I know how to make things. And so I just by drawings and photographs and physical modeling, that's how I would and then it's like you have the model of it, and then you just put it on different fulcrums, and you find out from this angle, like where its center is. Exactly. And yeah, it's literally not rocket science. It's actually just brutal, just crunching, physical crunching. But thank you.
Well, thank you.
We've got a question that came in here from Kate Kerr. She says, I make mounts in an earthquake zone and often have to work with glass shelving. Do you have any successes in how to discreetly attach to glass? I think, Monica and Ted, were the acrylic bases you were using waxed to the glass shelves, or were they allowed to slide?
So that was the thing with the, so some of them were, if they were a broad base and the objects were light, we did not do anything to secure them. And the ones that had the heavier objects that were tall and off, and with the smaller base, like the umbrella handles, we double-sided taped them. We didn't, we just used double-sided tape. And I think if we'd had double-sided tape all of them, we would have seen a lot more damage. I think those pickle forks and letter openers would have jumped out of the or out of their mounts. And in fact, there was another set of napkin ring holder, or napkin rings, I guess. They're made of ivory. They're just basically rings. And those also were, the acrylic bases were double-sided taped, and those came off of their mounts as well. And so I think you would have to decide on the mount combo. So if you have a grippy mount that completely encapsulates the object, then attaching the acrylic to the glass would have been fine. But in but otherwise I wouldn't recommend it. Actually, I would recommend, unless it's going to slide into another object. I mean, obviously you have to consider that, but I don't know if other people, this is what we did for the glass shelving, is we used acrylic bases, but I'm sure there's other techniques.
So the double stick tape worked well.
It did, yeah. It was just the 3M 415, I think, or whatever that number, sort of standard double-sided tape. It wasn't anything super strong.
This is a response to that question, but not a answer to as to what to use on the glass shelving. I was advised years ago, if possible, when dealing with design, to not use glass shelving, to instead use plexiglass. Now, then you can mount to it, obviously, but the issue is in an earthquake event like they had in Anchorage, if you have glass shelving, there's the potential that it shatters. The objects drop off it, the glass drops on objects on a lower shelf, et cetera, et cetera. So that was just something I was advised of years ago. But while I'm speaking, I just had to ask a question of Monica and Ted. Thinking back to your photo of the ivory umbrella handles, prior to the earthquake, it looks like you mounted it so it was sort of half surrounded on each side as it stood vertically. Following the earthquake, would you have something that surrounds it entirely? In other words, it looked like it might have moved to one side before it moved to the other side because the mount allowed it to do that. Would you now approach it in a way that would hold it all the way around?
Yes, I came in post-earthquake. I was unfortunate and fortunate at the same time to not be there at the time. I was unfortunate because I couldn't assist in the damage and cleanup. Fortunate I was not there to experience it. But no, after I was asked to come in and mitigate some of these mounting situations, and these mounts are that's the goal. Is as Vincent brought up about the aesthetics of a mount, I mean, you have to be very careful. You do want to get something that can encapsulate that, but without totally encapsulating it. You know, so there's a point, and there's, besides the center of gravity, there is this point of I call it release. So if you have enough wrap around, you don't have to go maybe more than you need to, and it goes back to the aesthetics of the object, especially on some fine, small objects. And so yes, our mantra is to secure as best as possible around so that it does not, there's no release points. I see what you're saying. I saw that in the photograph, yes.
Ed and Monica, one point that you guys brought up, which was I thought was really a good topic, was the fact that, you know, what the kind of damage you saw from temporary walls, and you know, that's something that might not always be taken into consideration, you know, versus a permanent wall or a structural wall in your building. And I'm glad that you brought that up, because it does something that needs to be taken into account of you know, taking that sort of holistic approach, as you know, Jamie was mentioning, and just thinking about all the aspects of how your display is put together. But thank you for bringing that up, because that was a really important point.
I think also, you know, we have like that particular temporary wall was made by contractors who don't normally work for our exhibitions department. It was made by a different company that was, you know, contracted to help for a variety of reasons, and maybe it wasn't on their mind. Whereas the contractors that we use, that the exhibitions department uses regularly, those temporary walls, I think, I don't know, Ted, you could speak to that maybe, but the temporary walls that are that we use in the Chipperfield edition, I think those were made either in-house by Rex or were they made by DBS? But I think, I mean, it made a difference, the people having experience who made the temporary walls. It wasn't just this, you know, people who don't work in museums sometimes don't think about these things.
Right.
And so, I mean, they're wonderful contractors and they build buildings all over the city and state, but they perhaps didn't really think the ramifications through of how easy would it have been to secure it to the wall behind it, which is a structural wall,
Right.
instead of having it in it, because it abuts next to it. It just doesn't, it only is connected at the floor.
Okay.
So, Monica, can I just ask a further question there, because it was in our Q&A earlier from Jonathan. But can you talk a little bit more about the case failure versus the object mount failure?
Sure. And I told these lovely panelists before, is I don't like to point blame at any one person, because especially, you know, a lot of the mount decisions were driven by aesthetics and curatorial. So speaking to the glass shelf, as a conservator, I would never agree to a glass shelf, but I didn't have a choice. You know, that was a decision that was made beyond us. And similarly with the kind of approach to the mounts is, you know, I agreed to it. It's my fault just as much. But I think that there's a lot of I wouldn't call it failure, as opposed to a lot of different factors all came together that resulted in this one instance. Because we also, I didn't go into this, but this earthquake was unusual. It was a very jarring earthquake. It wasn't a rolling earthquake. And for those who live in earthquake areas, you know the difference. And we get them all. We have earthquakes all the time. They're constant. But generally, you know, the ones that are the jarring ones are usually when the tensions build up between the plates, and then suddenly there's something that gives. But there's also directional. So that also contributed, is the fact that this particular earthquake went east-west, not north-south. And that caused damage that we couldn't have predicted. And so I think they all kind of come together. And that's for me, the hardest part about moving forward in the future, is trying to think of all those different factors. Because we used to be like, well, you know, they're mostly, you know, we mostly get these big rolling earthquakes. I mean, that is the biggest earthquake since 1964 up here. I wasn't around then. I don't think Ted was around either, or lived up here. And we didn't have experience with something so large. But now, of course, it's different. Now we think, oh, there's going to be another large one. You know, it's probably not going to be another 60 years. It'll probably be less.
Right.
I'd like to loop back to that, and something that you mentioned in the presentation about objects not jumping out of mounts. Speaking as someone who has seen evidence of objects jumping out of mounts because they didn't have a vertical restraint, I think it's worth discussing a little more. I did take a little time to look back at that earthquake that you experienced in 2018, which was described as a dip slip quake. So apparently the Pacific plate kind of bent, and you had movement derived by that, but it is a subduction zone that you're in, where the Pacific plate is diving underneath the North Pacific plate. And that's where you can get tremendous vertical forces. You know, if you get a subducting earthquake, things have a lot more vertical potential. And I just wanted to make sure people were aware that depending on the type of earthquake you're encountering, you can get tremendous vertical uplift. And of course, you never get to choose which earthquake you're getting. So you don't know what the next one would be, if it's rolling or has a big vertical thrust. But, you know, speaking here from representing the Getty Museum, we always try to provide vertical restraint because we have similar conditions to you, and we feel it's always best to be prepared for vertical uplift and the chance that an object may indeed jump out of its mount if it doesn't have that restraint.
Mac, if I might add it, during the Loma Prieta quake, I wasn't here. I came in right afterwards, but I saw the aftermath, and it was described to me in great detail. We didn't have, you know, giant vertical accelerations on that site, but objects did fly out of their mounts, like heavy objects took off. And so this was the building responding to the input of lateral vibrations hitting the building, and then the building's response was very unpredictable. That's the reason why we moved, because that building was was rated like it was like on the bottom scale of like what should be seismically safe. But yeah, again, we need to not just look at the earthquake, but the building response, and be prepared for, if we can be prepared for almost anything.
And Vincent, I think you brought up a great point in your in your question and answer after your presentation, was that you've got to treat it like it's going to happen at any point, and you can't necessarily pick and choose, like this is a temporary exhibit, or this is only going to be up for X amount of time. I mean, you have to assume that it's going to happen at any point, and
it's going to be on my watch. It's going to
right.
It's like, I don't want to take that responsibility.
No, I'm always happy at the end of an exhibition. I'm like, I dodged that bullet. But but we have to keep that always into consideration. And I'm glad you brought that up.
Well, Monica, I just want to say, Monica showed this a couple of slides of the bowl, Monica, in the Alaska exhibition. It was very lightweight, just laying in its cradle, that you said did not move out. You remember that?
Yeah, but I think that goes back to what Vincent and BJ both and Mac brought up, is that those cases were bolted to the cement floor, so those cases didn't transfer,
right,
and they didn't move in the same way. I really don't know why the objects on the third floor of our Chipperfield edition, which is the moving kind of building, why they didn't, but we didn't have objects that were in cradles move out there as well. And it might be that just that particular earthquake didn't cause a big jump, or the building absorbed it, or there's lots of things that could have happened. The ground, like below the building, also, and how the foundation is. But I think Jamie had something to say.
Yeah.
Well, I was kind of wondering, it ties into all of these things of displacement, the ability to move side to side or whatever, which you showed in the pickle forks and things which weren't tied to the glass shelf. And I know the Getty has worked for years to be making base isolation. And so there's these, kind of two different ways of looking at it, in terms of tying everything down and holding on real tight, or letting things move around and trying to keep them from their writing moment, from tipping over. And do people have, I feel like with small objects, especially with a base plate that has sufficient footprint, that not tying them down can be overall a good thing. And in terms of tying down the base, not, retention on the object is I think always going to be needed. But I just kind of want to throw it out there as to people's theories about when it's appropriate to allow something to slide versus when you want everything all held tightly.
And regarding that question, I had a question for Monica about the objects on pedestals that weren't anchored down to the floor. Did those tend to walk across the room, or did they stay sort of centered where they were?
So depending on the building, so the ones that I showed, they maybe moved at the most a ½ inch. They didn't actually move, but in that particular building. And then on the first floor, where those ceramic large sculptures were, those bases didn't move at all. They were on the first floor. I mean, we have a underground garage underneath it, so that there is a basement. But definitely the first floor pedestals did not move. But on the second floor where all those pedestals are secure. We did have a 3,500 pound canning machine or processing canning machine that moved a foot. And that was a big heavy object. And prior to this, I was like, oh, it's never gonna move. We don't need a mount. And obviously not very smart on my part. Should have consulted an engineer. And but luckily it was on its own. It moved a foot, but all it did was scratch the deck. It didn't go anywhere. It didn't tip. It didn't hit anything else, I should say.
It didn't fall off of its pedestal. It didn't move.
No, it was on a very large, low platform again. But yeah, and I don't know about other people's experiences with their buildings and with their pedestals when they've had earthquakes, or their memories of what that might be. That'd be interesting to hear.
I'm going to have to call time, unfortunately. Thank you guys so much. Over to you, Mac, to round us up.
Very good. Well, thanks for everyone's attendance today.
Yes,
At 4:15, we're going to have a tour hosted by Brett Angel at the MFA Boston. And if you haven't already signed up for that tour, you can still do so at mountmakersforum.net. I should mention that you will be held in a waiting room once you engage with that tour until 4:15. So don't be put off by the fact that nothing's happening. There's just a waiting room where you'll be parked, in essence, until 4:15. So thanks very much. You can also stay right here to see the wonderful poster presentation by Rick Hards and Jessica Arista from the Getty. And as you view the poster, please add any questions to the Q&A. They'll be available in the chat and Q&A functions to answer any questions you may have from 4:45 to 4:55. Thanks very much. Have a great break, and we'll see you back here soon.